Hello, everybody. My name is Alan Evans. I'm a co-director with Pedro Valdez Sosa of the Global Brain Consortium. Welcome to the annual meeting of the GBC. The GBC meeting this year is associated with a much larger program, the Belt and Road International Conference on Advancing Population Brain Health through Brain Apparatus Communication, organized by Pedro Valdez Sosa and his team. It's a very large program, 31 symposia, over 250 speakers. I've never seen a meeting so large. But we have a much smaller and focused program on the Global Brain Consortium. This is the online program. We feature 6 keynote lectures, 6 symposia, a lot to get through. I will also introduce a little later the Vera Gross lecture from Michael Breakspear. So we're very excited to hear from all of these speakers over the next 3 days. Let me tell you a little bit about the Global Brain Consortium, its origins and its reach. The GBC started about 5-6 years ago as an organization, a meta-organization to democratize brain mapping practices for low and middle income countries. We're starting with EEG technology because it's inexpensive and it's high temporal resolution. The GBC's project goals overall are to increase access for LMICs to electrophysiology, data, tools, methods, and infrastructure, to develop collaborative neuroscience, best practices for international open science, applications for disease disorder discovery, and equitable global mental health. The consortium is a meta-organization, as I've said. We have a steering committee made up of Pedro and myself as co-directors and a very high-profile set of colleagues on the steering committee. Some of these I will mention their involvement as I go forward. The GBC has had meetings from 2019, originally in Montreal, but then in Cuba and other countries, as well as virtual meetings through the COVID experience. There are a series of individual projects that take place underneath the aegis of the Global Brain Consortium, as listed here. A methodological harmonization EEG program led by Pedro and Hoy Bosch-Bayard. And then you see individual projects on early adversity, dementia, COVID, Parkinson's disease, electrophysiological approaches to dementia, and child brain development. This slide is an important one because I will throw a lot of acronyms around. The most important point to make here is the Global Brain Consortium sits on top of a series of different initiatives which provide platforms and technology to support their activities, and the GBC is the beneficiary of all of those infrastructures. There are many related network initiatives on the right here, which are contributing technology or science to the Global Brain Consortium's global outreach, and some of those will be mentioned shortly. The GBC in 2022 concluded an agreement with the International Federation of Clinical Neurophysiology, particularly through Paolo Rossini, who's a member of the steering committee of the GBC, to develop EEG methods for early dementia detection. The GBC has been active in presenting congresses and workshops at the ICCN in 2022, the local organizing symposium at OHBM in Montreal, and an educational course at the OHBM meeting in Seoul just this year. Mike Milham at the Child Mind Institute in New York, and his work with the Stavros Niarchos Foundation to explore a global adolescent mental health project, a very large project globally. The CMI under Mike and our own group are working together to integrate technologies that were developed at the Child Minds Institute, MindLocker technology for data acquisition of behavior. And that is being linked to the Loris environment developed in my lab. More about that in a moment. Faisal Mushtaq is one of the leaders of the Born in Bradford initiative in the UK, which originally was looking at approximately 14,000 children from economically deprived areas of Bradford, collecting genetics, cognitive, and school health care records. More recently, they've expanded to 24,000 children and include now EEG data, which will be supported by technology from the GBC. In my own context, the Healthy Brains, Healthy Lives initiative is a large program designed to create a global center of excellence in neuroinformatics and use that platform to translate discoveries to improve brain health. Most importantly, for the context of this presentation, a major theme in the HBHL canon is the development of a horizontal platform for informatics and computational modeling, which supports a series of projects which explore brain connectivity at a systems level and the changes in those connectivities for brain disorders, psychiatric disorders, and neurological disorders. Now, the technology that underpins these projects, principally the Loris databasing environment, which allows us to capture imaging, genetics, epigenetics, behavioral, clinical information, biospecimen information, and electrophysiological information under one roof, and to process those data with the CBrain high-performance computing portal. CBrain has been around since 2009. It's 15 years old. And it was originally a portal to the HPC environment of Canada, but now it incorporates international HPC sites, European HPC sites, and cloud services. CBrain is in now at this point, it's over 1,800 users in 32 countries. And you can see on the bottom left there, the slow growth of the user community for CBrain. There are over 100 different complex containerized workflows that are used and available on CBrain. More latterly, we've been adding genetics, transcriptomics, metabolomic analysis beyond what has been there in the past, which mostly included imaging and behavioral analytics, as you can see here. More specifically to the EEG context, Jorge Bosch-Bayar, who is on the steering committee of the GBC, has led the introduction and containerization of the harmonized EEG, QEEG toolbox for EEG analysis on CBrain. You can read more about this infrastructure from these open source sites or these publications. I won't go into any more detail on that. These platforms support, as I said before, a number of projects and network initiatives. In our own context, the Canadian Open Neuroscience Platform allows us to share data and tools freely in an open context. Over 100 different workflows, as I said before, and about 75 different data sets of different stripe, which can be accessed through the CONP portal. Another network that is making use of the same infrastructure in the Canadian context is EEG.net, which, as the name would imply, is principally oriented towards support for EEG-related projects, both methodological and data sharing. You'll hear more about this from Christine Rogers during this meeting. And lastly, Catherine Ammons and I have been working for a long time together in the so-called Big Brain project, which has grown to be represented as the Helmholtz International Big Brain Analytics and Learning Lab. I will be on my way to this meeting tomorrow, which is why I will not be in Chengdu in person. Katrin and I will be hosting the Highball meeting, which is focused on the integration of neuroscience and AI. Probably are familiar with the Big Brain data set, which is at the core of the Highball initiative. What's important here is that we have developed tools to segment either the cortex, 6 layers of cortex on the left, or in segmentation of the cerebellum, And you see that these structural maps can be made available to support the electrophysiological evolution. So we're right now working on the use of the big brain data set as a platform, as a template to provide a higher resolution and inverse solutions of EEG. This work is currently being undertaken by Jorge Bosch Bayat. Further work that's building in this space is the work of Anastasia Gonzalez-Michans. Annie did her PhD with Pedro, is now doing a postdoc with me. She has developed an accurate and efficient simulation of very high-dimensional neuromass models, which is taking advantage of the extra information on layer structure from the big brain. And lastly, big brain is the Highball conference is taking place, as I said, in Italy, and I'll be on my way there. So it was a very quick overview of the GBC. This slide again is an aide-memoire to see how the GBC fits into these networks, these platforms, and these tools, as well as a series of related entities which feed into the GBC Meta Consortium.